Hello, everyone. हेलो कृतिका मैम। अरे मजा एकदम बढ़िया। सबसे पहले ये बताओ कितने लोगों ने मेरा यूट्यूब वीडियो देखा आज का? हाउ मेनी ऑफ यू सॉ माय यूट्यूब वीडियो टुडे? सही तो सबने देखा ही नहीं। तो अगर देखा है तो और लोगों को दिखाओ, फैलाओ, लाइक शेयर सब्सक्राइब करवाओ। और क्या, कौन सा वीडियो देखो? पीपल आर नॉट इवन अवेयर। हाय आदित्य, हैप्पी बर्थडे। इट वाज अ प्रीमियर, यस। ओपी प्रमोशन मेरा भी कर दो सर। तुम जिस दिन वेदांतु एज एम्प्लॉय ज्वाइन कर लोगे तुम्हारा प्रमोशन भी कर देंगे। हाँ, सेशन के बाद ही देख लेना सब लोग। आई विल शेयर द लिंक एट द एंड ऑफ द क्लास, ओके? बिल्कुल बिल्कुल। अरे तुम लोगों से बोलना मार्केटिंग थोड़ी है यार, तुम लोगों के लिए तो वीडियोस बनते हैं। तुम लोगों के लिए क्या मार्केटिंग? तुम तो अब घर वाले बच्चे हो। ना ना, आई डिड नॉट एडिट यार, वी हैव एडिटर्स, वी हैव सुपर डुपर ऑसम पीपल इन आवर टीम। हाँ एग्जैक्टली, ड्रॉप वाला वीडियो है एंड एट द एंड ऑफ द सेशन आई विल शेयर द लिंक आल्सो। आई थिंक कुछ लोगों ने शेयर भी कर दिया है, बट नेवर माइंड, आई विल शेयर यू द लिंक टुवर्ड्स द एंड ऑफ द सेशन। कौन याद दिलाएगा मुझे एंड में? हु विल रिमाइंड मी? अरे वाह, वेरी गुड, थैंक यू। तो सभी याद दिलाएंगे। चलो, ऑन दैट नोट एवरीबॉडी क्विकली से हाई टू योर क्लास टीचर्स, कृतिका मैम, पीके शर्मा सर एंड अंशुल सर। क्विकली से हेलो टू देम एवरीवन। हाँ, 25 मिनट वेट कर लो, मैं वीडियो देख रहा हूँ। शाबाश। ओके, your class teachers are saying hello back to all of you. Okay, I will share the link towards the end, Arshan. Okay, so everyone, let's come back. Let's come back, all of you. Let's come back and start our session number 5. Everybody's ready for the session? Shall we start? Write +1 in the chat box. Today Shimon sir did uncam. Okay, that's good. Nice, अच्छी बात है। That's good. सारे फोन से लाइक कर दिया। वेरी गुड राजकुमार, दैट्स लाइक माय स्टूडेंट्स। वेरी नाइस। ओके, चलो गाइस स्टार्ट करते हैं। एवरीबॉडी रेडी? राइट +1 इन द चैट बॉक्स इफ यू आर रेडी फॉर द सेशन। दैट्स गुड, नाइस। ओके, अरे मेरा बर्थडे नहीं, आदित्य राणा का बर्थडे। चलो एवरीबॉडी, स्विचिंग ऑफ द चैट क्योंकि अब थोड़ा सा डायरेक्शन गलत जा रहा है। लोगों को लग रहा है कि आज मेरा बर्थडे है। मेरा बर्थडे आज नहीं है, जब आएगा तो बता दूंगा। अगले महीने में है मेरा बर्थडे, ठीक है? तो मैं वेदांतु का एड्रेस भी शेयर कर दूंगा। आई शेयर दी वेदांतु एड्रेस एज वेल विद ऑल ऑफ यू। जो गिफ्ट भेजने वहां भेज देना, वहां से मेरे पास आ जाएंगे, ठीक है? चलो, इनफ टॉक्स, लेट्स स्टार्ट टुडे सेशन। दिस इज आवर सेशन नंबर 5 एंड today we'll be speaking, or rather we'll continue something that we started last time. Okay, anticipating that today's session would get longer, that's why I picked something from today's session and the previous one and started it then and there itself, because we finished a little early last time. Okay, so we spoke very little theory about last time, and theory was an extension of torque. We first understood in previous class what exactly torque is, what is its role, and after solving a lot of questions on torque in the next, as in the previous session, we spoke about another application of it, and that one rigid bodies. So we derived this expression tau equal to I alpha, and it is equivalent to F equal to ma. For those who have forgotten, the role which was played by this equation F equal to ma is played by tau equal to I alpha here, right? Counterparts. So exactly the same role is being played by this equation as it was played by F equal to ma. So it means not officially, but unofficially you can call it second law of motion, but rotation motion. So this is second law of rotation motion for us. Now don't ask me, sir, is there a first law, is there a third law also? There is no official second law of rotation motion. It is only the parallels that we are drawing. Okay, please don't ask this question to your class teachers or to me towards the end. This is just trying to make you people remember the equation. It resembles a lot with whatever we have studied in the translation part. Okay. Then very importantly, we talked about finally the pulley with mass. Little realistic situations we spoke about where pulleys will have mass and the blocks already have masses. String is still ideal. In the next page, I will show you the expression also. And then we introduce the concept of angular momentum, and we realize it is also again can be drawn the counterparts with. So if we speak about the equation P equal to ma, which is basically linear, sorry not ma but mv, linear momentum is equal to mass into mass into velocity. Sorry, slip of tongue. So angular momentum is going to be mass. The counterpart is I. V counterpart is omega. So that is one. And for circular motion also be defined. I'll come back to that part. Today we'll quickly go through that once again. Speaking about point number 2 once again. So we derived this expression. Before that, we spoke about how the tension in both sides of the strings are not going to be same. It's a quick recap for all of you. If I say the spring on the right hand side has tension T1, then the spring on the left hand side will have tension T2, and whichever side the masses are coming down, that tension has to be more. Or basically, it will depend on how the pulley is rotating. If pulley is rotating clockwise, then definitely T1 is greater than T2, and if the pulley would be rotating counterclockwise, then definitely T2 has to be greater than T1, so on and so forth. More importantly, after getting the expression of acceleration for this given situation, we found a shortcut, but it is very risky. Unless you totally understand this, you should not try this. Okay, so it is driving force minus opposing force divided by mass of the blocks plus moment of inertia of pulley by r square. By the way, if you remove this part, then the expression is actually from laws of motion, where pulley did not have mass. Then the answer used to be this. And now because the pulley also has mass, so moment of inertia of the pulley divided by r square. By the way, pulley is always considered to be a disk. That means moment of inertia half m r square, always and always. Okay, everyone, we understand this properly? Good. Shall show me by solving these questions quickly. Question number 1 for all of you. A torque of 10 Newton meter is applied to a flywheel. Flywheel is a disc of mass 10 kgs and radius of gyration is given. Radius of gyration is given. The radius of the body is not given. Okay, so you will have to find out the radius of the object, or maybe find out the moment of inertia of the object. It's up to you. So what is the resulting angular acceleration is what you have to find out. All I can say, you will require tau equal to I alpha. You want to find out the value of alpha here, and I will give you, looking at the option, 60 seconds, and the time starts in 3, 2, and 1. Okay. Hmm. So how will I find out the moment of inertia? Because I already know the value of torque. If I get the value of I can directly find out the value of alpha as tau divided by I. So moment of inertia of any object can be written as m into k square. So question has straightforwardly given you all the information. It has given you the mass of the flywheel, that is 10 kg. Radius of gyration is 50 centimeters square. Okay, sorry, 50 centimeters. So you have to convert it into meters. 50 centimeters is half a meter. Square that value. So 1 by 2 square that, it is 10 by 4. Okay. So the value of alpha, which is tau by I, is equal to 10 divided by 10 into 4. Without even doing any sort of slaughtering of numbers, we get the answer. 4 radians per second square. That's an answer. Okay. Good. Sure. One more. A uniform ring starts from rest and acquires an angular speed of 10 radians per second. Okay, and that too in 2 seconds. So it's a ring. The mass of the ring is given, its radius this time is given, and the torque on the ring should be how much? So again, tau equal to I alpha based question, giving you guys 60 seconds. Once again, remember to solve the question in SI unit, and your time starts in 3, 2, and 1. Okay, last 10 seconds countdown going on. Mhm. Okay, so again, this time it's a ring, so moment of inertia of a ring is mr square about its usual axis, and from there you already have the value of omega starts from rest. That means omega naught is 0. Omega is given, so alpha is going to be changing omega upon change in time. So omega is changing by 10 into, so this comes out to be 5 radian per second square, very easy. The moment of inertia, excuse me, is mr square. Mass is half a kg, we all understand 500 grams is half a kg, and radius is 20 centimeter, 20 by 100 is 1 by 5, square that value 1 by 25, so this value is 1 by 50, okay? So tau, which is equal to I alpha, is 1 by 50 into 5, so 1 by 10, that means 0.10 Newton meter. Answer comes out to be option C, okay? So simple it was. So let's continue where we left our session last time, where, okay? So we left it at angular momentum. I gave you a basic preliminary idea of what angular momentum is. In fact, I gave you people a very important idea about angular momentum, not just preliminary idea. Okay, I told you people that for a circular motion performing body, okay, we spoke about this very much in depth. I told you that when a body is performing circular motion, okay, so maybe the body is the one which is represented by red dot and has some linear velocity v, and it is moving in a circle of radius r. Then its angular momentum was found as r cross p. This is written for a point mass. This is in general how you represent angular momentum for circular motion. You know that r, p both are perpendicular to each other. Right? Why this is so? Because if you look at it from the top also, the radius and tangent both are obviously perpendicular to each other. So that's why this angle is always 90 degrees. So for circular motion, only for circular motion. Okay. For circular motion, theta is equal to 90 degrees, so L will be equal to R into P into sine of 90. Angular momentum comes out to be R into P or R into MV. In other words, you can write it as MVR. This is what the angular momentum only and only. Remember, this is the expression only for circular motion. The generic expression is L cross P. Okay. Now, the more important part was if a body is moving in a straight line. If a body is moving in a straight line and we want to write its angular momentum about, a point which we can consider like origin or axis of rotation also. So say your body of mass m is moving with velocity v and continuously going in the x-axis or parallel to x-axis, and you want to write its angular momentum. You will say that still the angular momentum is m into r cross v. Okay, that is basically basically r cross p. It is so mass is something which is a scalar quantity, so taken out of it. So only r cross v is what is happening. Or you can also write just r cross p if you want to write down m and v together. So point is, guys, when we write this from magnitude point of view, we find out that it is mv r sine theta. And my dear friends, need your attention on this right angle triangle. You see that this distance is basically r sine theta. This distance is r sine theta. So this is also r sine theta d. So we can say that this r perpendicular that is written here, I call it d. So you can write this angular momentum as m into v into d. More interestingly, I explained you guys, doesn't matter how much this body travels on this green line, does not matter. As long as it keeps on moving on that direction, theta keeps on decreasing, r keeps on increasing, r sine theta remains a constant. Means what? Even if your object which is moving, say the object reaches somewhere here. Now what you can see, the same r vector now is making a different angle, that is alpha, which is smaller, and r dash has increased. But r dash sine alpha is still going to be d, because now also it is part of a right angle triangle. Okay, everyone remember? And today we will see how it becomes so helpful at times whenever we will require it to be. Okay. So this is one thing. Second thing was actually very easy to understand and compare with. I told you about this in today's beginning also, that we can compare angular momentum for a rigid body similar to a body which was performing a translatory motion, and the expression will come out to be I omega. Okay, so for a rigid body, the angular momentum will be represented as I omega. Okay, because of the polling thing, I'm not able to see what exactly is written before L equal to I omega, but whatever it is, it's basically L equal to I omega, which is comparable to P equal to MV. Okay, everyone switching on the chat, everybody is with me so far. This is something that we covered till last time itself. This is still revision for all of us. Okay, perfect. Everybody has played pen fight or seen people playing pen fight. Is that game still valid? Is that game still exist? Does that game still count in schools? Okay, so everybody knows it. Okay, you lost your pen in this game. Okay, I understand. My sympathies. So the point is, when you play pen fight, it is played on a table. You place your pen, you hit it. Now, when the pen is hit, it definitely rotates. You must have seen, right? But it doesn't only rotate at its own position. It also goes forward, right? That means it is rotating and it is translating. You can try this today once again. You can bring back your old memories. When you hit the pen, there is a particular point about which your pen rotates. Okay, there is a particular point about which your pen rotates. Do you know what is that point? That's a special point. Now we know that point. It doesn't rotate about its edge. It does not rotate about its edge. ऐसे rotate नहीं करता है. It rotates about the point where we can say the center of mass lies. And something that I want you people to keep a mental note of. Listen to me carefully. Whenever a body freely rotates, when I say freely rotates, when it has not been hinged, like your door is hinged. It has no option but to rotate about that axis only. Your pen, on the other hand, does not have a fixed point. Every object which is not hinged and it is still allowed to rotate freely will always rotate about an axis which passes through its center of mass. Can you people remember that point? This is a practical thing. Whenever a body will freely rotate without any hinging, the axis will always pass through its center of mass. Okay? Awesome. But yeah. Okay. So now the case that I'm talking about. I can understand Pradipta. Schools are closed but expected to reopen. Just a second. So everyone, now the pen fight situation is going to be the combination of case 1 and case 2. That means what? If your pen is allowed to rotate only about an axis like this, then it's like your ceiling fan. It's like your door. It's like any windmill where the object is purely rotating. So the angular momentum will be written as I do omega. But now this object is also allowed to move forward. Okay, so it is rotating and it is going forward also like this. So that means what? The body is rotating, angular momentum I omega, but its center of mass is translating. So the angular momentum will also be mv r sin theta for the center of mass. So when you write third case, try to understand this properly. When you try to write the angular momentum of a body which is rotating plus translating, first of all you need to talk about a point about which you are trying to define it. So maybe this is your axis of rotation. Okay, this is your axis of rotation, and this is your body which is rotating freely and going forward also. So for the translation motion of the body, you cannot speak about the translation of each and every point. That was the whole point of defining center of mass, because the motion of each and every point is complicated. It's not even circular. It is not even any easy motion to look at. The motion of each and every particle is a very complicated motion. So the point which represents the motion of entire body in the form of translation is the center of mass. So maybe your center of mass is performing a translatory motion. So you will write the angular momentum of the center of mass and the momentum of angular momentum of the entire body like this. Okay, so you can write down the body's moment of angular momentum about an axis which is passing through its center of mass. This is what basically we call it I omega. Okay, this is what is I omega. The momentum about the axis when the body was only rotating. Means again giving you an example of your pen. If your pen rotates only about one fixed axis, it does not move anywhere, like your ceiling fan. So now it is rotating about its center of mass. Momentum becomes I omega. Angular momentum becomes I omega. But if it starts moving forward, so its center of mass is moving with a velocity v naught at a distance r naught from the axis of rotation. So what you are writing here is the angular momentum of the center of mass. Please do not misinterpret. This is not angular momentum of center of mass. Remember, it is written also. LCOM is the angular momentum of the body as seen from the center of mass frame. I'll write it in a very simple words. Okay, I'll write it in very simple words. LCOM, my dear students, is the angular momentum of the body about an axis passing through center of mass. This is what is LCOM. Okay, and what is m r naught v naught? Angular momentum of center of mass about 0.0. Does this make sense? Please write +1 if you understand. Right, everyone? Very good, everyone. So whenever that situation will come, we'll use it. As of now, let's go forward and look at more problems to solve. Before that, there is one more correlation that we need to do with what we studied there in translation. So all of you, we have seen this equation many times now, tau equal to I alpha. We know we can write alpha as rate of change of angular velocity. Angular acceleration is rate of change of angular velocity. And take this I also inside, so we can write it as change in I omega by delta t. And what is I omega? We just now figured out, we just now found that I omega is nothing but angular momentum. So torque is equal to delta L by delta t. Does it remind you of something that you have seen before? All of you, what we used to call this equation? This is basically the second law of motion. This is second law of motion. That the force acting on a body was equal to rate of change of linear momentum. So the torque acting on a body will be equal to the rate of change of angular momentum. Okay. Every session, every slide actually tries to give you a nostalgia or haunting of whatever you have studied in physics so far. It is just a recap through rotation, right, everyone? Yes, yes. So what do we expect? There used to be a law of conservation of momentum. Yeah, when no external force was acting on the system, the momentum of the system was conserved. So that's what we are expecting today. That is what will happen today. When torque external will become zero, angular momentum will become conserved, and that's a very beautiful thing to study. Okay, we'll actually get into the depth of that while problem solving will be done. So, फिलहाल चलते हैं. Yes, let's go forward and solve some questions quickly, all of you, so that we spend more time on law of conservation of angular momentum. So, question: a constant torque acting on a uniform circular wheel changes its angular momentum from a naught to 4a naught. For a change, they are just representing angular momentum by capital A. It is still the same quantity. So, it is changing from a naught to 4a naught in a time that is 4 seconds. So, find out the value of the torque. So, you just now solve the equation. Just quickly solve it, giving you 45 seconds. Time starts in 3, 2, and 1. Don't rush. Try to be accurate rather than try to rush. Okay, all of you. Okay. अरे यार, ये तो होना चाहिए था. I told you people not to rush, but you guys are actually trying to be in the fastest finger list mode. Don't try to do that, guys. We have to be more accurate, okay? So torque is change in angular momentum upon change in time. Angular momentum becomes 4a naught. Initially it was a naught, so change is 3a naught, and this happens in 4 seconds. So this is 3 by 4 a naught, as simple as that. Oh, I get it. Your confusion, I get it. I get your confusion, guys. But इतना figure out कर लेते हैं. We are not new in JEE preparation. We are not new in JEE preparation now, right? Okay. Nah, will not give you a benefit of doubt on that. Sorry. Chalo, we got this. The value has to be 4 here. Theek? Awesome. So this is done. Next question, all of you. Now this one will require you to do calculation, so be ready. A 40 kg flywheel, once again a disc, in the form of a uniform circular disc. Oh, it has already mentioned that it is a disc. So it has a radius and it is making 120 revolutions per minute. It is not SI unit system. Okay. Okay, and you have to find out the value of angular momentum. That means L equal to I omega. I can also tell you I value will be half mr square into omega. That's what you have to do. Giving you full 2 minutes for this because calculations are involved. Be very careful with the units, okay? And accordingly try to find the answer. And your time starts in 3, 2, and 1. Last 10 seconds. Okay. Again, nothing to be, nothing to actually worry about this question apart from just the calculations of it. So if you will just put the values correctly, only thing, omega, which is given to you in RPM, you know that in one revolution or rotation there are 2 pi radians, and in 1 minute there are 60 seconds. So you cancel it 2 times, and 4 pi radians per second is basically the value of omega. So you just have to find out I and multiply it with omega. Do that, you'll get the value. Okay, so 4 pi, as I said, is the value of omega. We found that value. Moment of inertia is 20 kg meter square. Let's multiply that. We'll come out to be close to 251.2 kg meter square per second. And there was one more hint actually in the options. Not so close, but not so far away options. These are all, these are not proper SI units. Only option B and option D were in SI unit. That's why. Okay, right? Sure. So let's get into better discussion, and that is about conservation of angular momentum. And actually, no surprises, it is exactly on the same lines as it used to be about the conservation of linear momentum. But yes, definitely, the objects are rotating here. Okay, or there is a possibility of at least a rotation happening. Okay, so when we speak about this situation, it's actually going to go on the similar lines. If you people remember, we defined the external torque acting on an object to be the rate of change of angular momentum, which is written already. Why am I writing it again? So if the external torque acting on the system or the body becomes 0, then the angular momentum of the system will remain conserved. Which means what, guys? The value of I into omega, the value of I into omega becomes a constant. This value becomes a constant. Okay, let me look for a practical application of it in the form of a graphic image file. Okay, do I have it? Doesn't look like we have here, but maybe I'll find it when we're solving a question. See what happens. The statement is actually very straightforward. It says that in a system, if there is no external torque acting, then the value of the angular momentum of the system will remain conserved. Now, does it mean that there has to be a collision? Here, the only thing which is not necessary that the system requires a collision to happen. In fact, it is possible for a single system without even collision, the momentum to remain conserved. Okay. The best of the example is what I'm going to show you in the form of a video, also a small video, and I will give you more of such explanations. First, try to just have a look at it. Meanwhile, oh my God, why is it not loading? Please load. Hmm. Let me retry for this to load. Okay, I'll share the screen so that you guys are able to see this. Angular momentum conservation. Okay. Specifically, this one I want you people to see. Okay. This is one of them. Second one. Oh yeah, this one. Hold on a second, guys. Graphic image is what I'm looking for. Yeah, found it. Found it. Okay, so I found one and I found another one. Exactly. Okay, everybody. So I'm going to share my screen. Oh, you can see it. Are you guys able to see this? Because I'm not able to see it. Yeah, many of you guys are not able to see it, right? That's okay. So everyone, sharing the screen so that you guys can see this. Okay, so have a look at this, guys. See what is happening. The size of this entire imaginary, or means not imaginary, it's a spherical kind of arrangement. See, the velocity is less. The angular velocity is less. The moment the object shrinks without any external torque acting, the force which is applied by the thread, by the person, is passing through the center of this object. That means the force is not going to apply any torque. The thread is such that when you pull it, the force will only try to do some translation effect, will not try to do any rotation effect. It is only compressing the object. And the moment object compresses, particles come closer to the axis of rotation, moment of inertia decreases. And if moment of inertia decreases, everyone, I'll write it down after something. It is angular momentum, which is I into omega. If I decreases, omega has to increase. That's why this thing starts to rotate faster. Have a look once again now. Now see, I increased, omega decreased. We'll pull it again, I will decrease. Moment of inertia will decrease, angular velocity increases. Okay. Now another one, all of you, have a look at this. See this dancer, when she brings her hands closer, her angular velocity increased. when her hands and the body parts are actually far away from the axis of rotation. See, hands come closer, angular velocity increases. Again, hands will go away, angular velocity will again come back to normal. Okay, all of you got the idea, right? In both the situations, pay attention. Okay, so pay attention now. In both the situations, there was only one object. Like that dancer, she was the only object. Nobody, externally applied any force on her. She herself just pulled her hands inside. Her angular velocity increased. Why? Because the moment you bring things closer to the axis of rotation was passing through her body. She brought her body parts, especially hands and legs, closer to the axis of rotation. Moment of inertia decreased, angular velocity increased. Similarly, during Olympics swimming diving competitions, not exactly swimming but diving competitions, you must have seen the divers whenever they are in the air, they try to bring their body closer to their axis of rotation, the way they rotate. In that, what happens? Moment of inertia decreases, angular velocity increases, so they are able to show more turns, and that is what I guess the skill is all about. And when they are about to touch water surface, they can open up their body so that they don't hit the water surface at a very high angular velocity because that will anyway damage their skin or skin cells. Examples clear, all of you? In any of the examples that I've given you, nowhere multiple bodies are involved. Okay. Yes. Now I'll give you one more example where two bodies are involved and collision also happens. And probably we will solve a question on that today. I'll frame the question. We will solve that question later. I'm going to give you the situation right now, which I spoke about last time also. Okay. So maybe say there is a massless string, and this massless string has a block hanging by it. The mass of the block is capital M. The size of the block is negligible though, or maybe its center of mass is somewhere here, and it is at rest initially. Okay. So the string is ideal. You know what ideal means now. Okay. And then what happens? There is a bullet. There is a bullet which is moving on this line with a constant linear velocity. This is a bullet which is moving with a constant linear velocity v0, has a mass small m. What will happen? This bullet is the only object which is moving before collision. Okay, and the motion is actually linear motion. Okay, but when it collides with the block, wooden block, it penetrates inside, stops inside the block, and then the block plus bullet system gains some velocity, maybe v1, and they start rising together. So they rise, and finally the entire system stops somewhere here. Okay, so one of the very standard questions is to find out the value of the height to which the system rises. So obviously you want to find out in that case the height to which the system has gone up by. Okay, so everybody, let me ask you one question. Can I say that in this entire system, O, the point O, is the axis of rotation? All of you? O is definitely the axis of rotation. That means a line coming towards you. But before collision, there is no object which is actually rotating. There is no object. The bullet is moving in a straight line. How will you write the angular momentum of it? You will definitely require the length of the thread, right? Say the length of the thread is L. Or say the center of mass of the block is at a distance L. Can we write down the angular momentum of the moving bullet? Can we now write down the angular momentum of the moving bullet? Remember this? Yaad aaya? Not MVR. We will have to write it as MVD. MVD is the angular momentum. So how will you write it? You will say that the perpendicular distance of this line is L. So the angular momentum initial is M into V0 into L. Getting it, all of you? Getting it? And after they collide, obviously they both will gain some velocity V1. How do I get the, by the way, what type of collision will you call it? If both the bodies combine together to become a mass of capital M plus small m, it is perfectly inelastic collision, right? So before collision, M V0 is the linear momentum. Okay, M V0 is the linear momentum, and after collision, M plus capital M into V1 is the final momentum. So what is the value of V1? M, मैं पूरा question solve कर दिया actually. अब कुछ बचा ही नहीं question में. I have done it everything which was needed. So we have got the velocity of the combined mass just after the collision. All of you get this? We have got the value of V1. And with this velocity, the combined mass starts to rise up. So can we say that from this point after collision is completed, which quantity do you think will remain conserved? Can we say the overall energy of the system will remain conserved? All of you? Correct? Perfect. Okay. So at times they ask you to find out the value of the angular velocity also. They also want to find out the angular velocity also. So in that case, you can apply the. Usually they ask this question by not giving you a block, they give you a rod here. I'll give you that question at the end. We'll do that question at the end. Right now, it is actually not entirely requirement of angular momentum here. Right? We will speak about a rod hanging. So when the rod will be hanging, then the angular momentum conservation will be applied. Okay. So now the combined mass is M plus M. We don't even require the angular momentum actually. So initial energy at A can be equal to energy at B. I'll tell you why angular momentum is not required. I'll tell you that also. Why do I not require the angular momentum or angular momentum conservation is because I can consider that both the masses are at a distance L. That means what? I can treat them as point masses only. Okay, I can treat them as point masses, so I don't need to write down the rotational kinetic energy, which we haven't even defined yet. I will define it today and I will explain it to you. But as of now, can I leave it to you guys to solve? At A, this is height equal to 0, so total kinetic energy is capital M plus small m into V1 square. And at A, the potential energy is 0. At B, the kinetic energy becomes 0. And potential energy becomes M plus small m into G into H. Simplify that and get the answer. M plus M gets cancelled. We get the value of H. But for V1, you will have to write, or you'll have to put the expression of V1 here. Make sense, all of you? Okay. So not entirely a question of rotation, but we will do that question today, or if not today, definitely in the next class. Okay, cool, awesome. So before we go any forward, yes, definitely 1 plus 1 minus cos theta L. Again, you people remember the concept of impulse. We spoke about the concept of impulse, and in a nutshell, we understood that impulse is nothing but rate of change, the change of momentum, right? So similarly, angular impulse is going to be nothing but torque acting for a short duration of time, or torque acting for a duration of time. So torque into the time factor is basically your angular impulse. Mathematically, you are basically going to find out the value of change in angular momentum. Whole NLM is rotation. In fact, whole physics that you have studied so far is rotation. That's what I said in the beginning also. Okay, all of you, shall we go to problem solving? Because I think we are almost done with the theory for the day. Also, there's only one more topic to cover today. That is kinetic energy. That's a $1 million question that you have asked today. Apur Srivastav, it's $1 million question. Give this guy a medal. चलो बहुत हो गया मजाक, लेट्स गो। चलो guys, jokes apart, let's start with the question. We have a person who is standing on a rotating table with the metal spheres in his hand. I would say any, generally the balls that we play cricket with. So we play cricket with maybe cork ball, synthetic ball, not plastic balls because they don't have much mass. They're not heavy. So that's why they're saying about metal sphere, because they have significant amount of weight. So a person is standing on a rotating table with the metal spheres in his hand. If he withdraws his hand to his chest, I would say that if he brings his hand closer to his chest, basically he reduces the moment of inertia. The effect of the same on the angular velocity will be how much, or how will you see that, is what the question wants you to find out. I want to set this question as a quiz because this could be free points for all of you guys. Okay. So setting up the quiz will give you only 30 seconds, and the time starts in 3, 2, and 1. Object rotates, brings his hand closer. What happens to the angular velocity of the system? The answer self-explanatory in front of you, right? So when he brings that weight closer to his body, you can see starts rotating faster. You guys can try that at your home itself, but उसके लिए तुम्हें कुछ ऐसा चाहिए होगा नहीं. You will require a platform which can self-rotate. Okay, so if you can arrange for something like that, this could be done. Okay, this guy is doing nothing. This guy is standing on a platform which can rotate. His friend has actually given him some angular velocity when his hands were away from his body. His friend has actually made him rotate. Actually, you can try this on a rotating chair also. If you guys have a rotating chair in your home, maybe your father is working from home, so he may be using it. So if you have a rotating chair, you can try it at home. Okay, but make sure your legs are not touching the ground, because if you will touch the ground, then you will be experiencing an external force, friction force, which will not let the momentum be conserved. So you have to have your entire body. Make your sibling or someone to rotate you. Maybe your hands are away from your body. Bring your hands closer. You will see your angular velocity increasing. Yes, definitely it will happen. Okay, good. So an experiment you guys can try. Yes, and because you want to observe it, make sure once you are being on the chair and then your sibling is on the chair. Okay, मैं चाहता हूँ कि तुम फिजिक्स को एक्सपीरियंस करो. That's what I want. Okay, उसके बाद में घर में कितनी पिटाई हो रही है, कितनी चेयर्स टूट रही हैं, उसका जिम्मेदार मैं नहीं हूँ. I'm not responsible for any of that. Okay. Okay, chalo guys. Switching off the chart, taking you to the next question. A child is standing with his two arms wrapped close to his body at the center of a turntable. Now, people who were talking about, a rotating platform in a park. Usually, there are rotating platforms in a park. So, a child is standing on that rotating platform with two of his arms wrapped closer to his body at the center of the turntable, and that is rotating about its central axis with angular velocity omega naught. Now, the child outstretches his hand. The previous situation which you saw, just opposite of that is happening. Initially, the hands are closer. Then he takes away his hands away, so that the moment of inertia, which was I, becomes 3I. So what do you think will be the new angular velocity? I'm not solving this also. I'm giving you people this question. It is a conservation of angular momentum because no external torque has been applied. Giving you guys this as a question will give you only 45 seconds, and it doesn't even require that much time, by the way. Your time for 45 seconds starts in 3, 2, and 1. Just previous question, but now moment of inertia is increasing and becoming 3 times its original value. What impact? It is something that you don't actually have to solve. Okay? You don't even need to solve it. Last 5 seconds. Okay? Yeah, verbal question. This is a verbal question. You don't even actually have to lift your pen for this. If I into omega has to remain a constant, tell me, if I becomes 3I, then omega has to become 1/3, right? It has to become omega naught by 3, so that the multiplication remains the same. That's it. Sir, if we take the example of rotating table where we eat, I don't eat on a rotating table. I don't have that extravagant dining table at my house. We have that usual rectangular table. We are still middle class people. Okay. So if you happen to have that dinner table, I'm sure your family will not appreciate you standing on that table. There are dining tables where there is a rotating table possible. Your parents will not let you have dinner today. They will not let you have dinner today if you will try anything like that. We'll say Suri sir said so. So what? Suri sir is not being deprived of the dinner. You will be. Suri sir will still get dinner. You will not. ठीक है? Exactly. चलो, बहुत मजाक हो गया. आगे बढ़ते हैं everybody. Suri sir will get his khichdi as always. All of you, next question. Two discs. Now this time, two objects are going to basically the third possibility where angular momentum gets conserved. I've shown you two. You have solved the previous two questions based on the first possibility. Second one I showed you when there's an object which is hanging, a bullet comes, hits it, angular momentum remains conserved. Third possibility is the one that you will see in this question. This question says that there is a disc which is rotating. There are two discs, moment of inertia I1 and I2, and they are having their own angular velocities, omega 1 and omega 2. Angular frequency means angular velocity. No confusions there, okay? Angular velocity and angular frequency means the same thing. So what happens? They both are rotating. They both are rotating, and you actually bring them on top of each other. So maybe one of them is rotating, other one is also rotating. You just place it somehow on the other one. So what happens? They both will try to create some friction between each other. But when they try to create that friction between each other, the friction is an internal force, and that internal force will create internal torque. That means no external torque acting. Makes sense to all of you? When you rub both of your hands like this, when you do this, The friction is an internal force, and the internal force is actually creating, if it is creating a torque, that is also internal, correct? That's why external torque is 0, and we can say that angular momentum will remain constant, conserved. So question is asking us to find out the angular frequency of the composite disk. So what has happened here? I'll show you the diagram of that. This is what has happened. Okay, I'll take you there. Yep. Just a second. You'll see the diagram now. Okay, so this is what is happening overall. So earlier, both of them have individual angular velocity omega 1 and omega 2. Now both of them are combined together to have effective moment of inertia as I1 plus I2. So very easily we can solve it. We will say that I1 omega 1 plus I2 omega 2. No picture is given. We will always consider the axis which is passing through the center of mass perpendicular to their axis, perpendicular to the plane. That is what you will always assume unless the diagram is given to you. But this question always comes like this only. इतने साल हो गए हर बार यही situation होती है. Okay, so omega is going to be very simply I1 omega 1 plus I2 omega 2 divided by I1 plus I2. That's it. That's your answer. So isn't it like perfectly inelastic collision? Technically collision है नहीं, rather practically collision है नहीं, technically है, हाँ बोल सकते हैं exactly. There is some loss of energy also because of friction. Because of friction there is a loss of energy also. Yes. ठीक है. So can you explain this? Explain what? What do you want to explain? Italian. So before they were combined, पहले वाले का angular momentum was I1 omega 1. Second one had angular momentum I2 omega 2. Now they both become the same object of angular moment of inertia I1 plus I2. They become one disk. So I1 plus I2. And there is no other, there is nobody from outside applying force on them. They are applying force on each other because they are placed over each other. That's why. So that's angular momentum is conserved. Clear? Good. Okay. Sure, guys. So with that, I'm sure others also understood. Let's see some examples by you guys trying this out. Question is: a ballet dancer dancing on a smooth floor. Ballet is a dance form considered to be one of the most difficult dance forms. Okay, where people have to actually dance on their toe. This is my hand. You have to dance on your fingers of your legs. That's called toe, right? So a ballet dancer dancing on a smooth floor is spinning about a vertical axis with her arms folded with angular velocity 20 radians per second. When she stretches her arm fully, the spinning speed decreases to 10 radians per second. If I is the moment of inertia before, then after she has stretched out her hand, what do you think will be the new moment of inertia? It's a very simple question, giving you guys only 45 seconds. Your time. This is the situation. Okay. This is omega 1. This is omega 2. I1, I2. I2 in terms of I1 has to be found. Your time for 45 seconds starts in 3, 2, and 1. Okay, that's good. Okay, so as you can see, all of you, angular velocity became half. So moment of inertia should become double without even solving. Has to become double without even any mathematics being done here. Okay, I1 omega 1 equal to I2 omega 2. This is I. This is 20. ये तो मैं सिर्फ लिखा हूँ, बाकी इसकी जरूरत नहीं है. Okay, you don't actually need to do all this. You know how to get this very easily, right? Okay, yes. Next one is again a similar question. A man standing on a rotating platform with his arms stretched holding a 5 kg weight in his hand. The angular speed of the platform is 1.2 revolutions per second. Answer options are also revolutions per second, so please don't try to change the units. The moment of inertia of the man together with the platform is given to us as 6 kg meter square. The man brings his arm closer to his chest with distance of each weight from the axis changing from 100 to 20 centimeters. So he is holding the weights. So person plus platform, the weight of that, or the moment of inertia of person plus platform is given. The moment of inertia of the two weights that he is holding is not given. You have to find that out. What is given to you is the initial distance of the weight from the axis of rotation and the final one. So you basically require to find out their initial and final moment of inertia, and then you'll be able to do the calculation of new angular speed of the platform. I'm going to give you guys complete 2 minutes for this. Do the math. Your time starts in 3, 2, and 1. Please do not rush. I'm sure many of the people who are in the fastest finger list will make mistakes here. Not that it's difficult or it has any tricks involved. I do not think this can be done in 30 seconds. One minute is left. Okay, last 5 seconds now. Told you, the people who will try to do it faster will definitely make mistake in this one, because this was not a question to be done in 30 seconds or less. Okay. Yeah. So first of all, the initial moment of inertia is 6 plus mass of the weight the dumbbell, and distance is how much? 1 meter. Square that value. So 11 kg meter square is the initial angular momentum. I2 will be person plus platform, still the same moment of inertia. Okay. Yes. And 5 is the mass, and 20 centimeter is what? 1 by 5. Correct. So 1 by 25 it is. So it means 1 by 5. 6 plus 0.2, 6.2 kg meter square. Okay. आगे की सब calculations हैं. I'll show you that. So 16. Oh, there are two masses. My bad. There are two masses. So this will become 10 plus 6. This is 16. This is into 2. So 2 by 5 is 0.4. So 6.4. Okay. 6.4, 16. Initial angular velocity, final angular velocity. Just equate both of them. Okay. All of you, no chit chat, no crosstalks. Simplify. We get the answer as 3 revolutions per second. Okay. Okay. Now the only concept that we are left today to study, and that is rotational kinetic energy. I'm not even sure whether it is actually today's topic or not. I've added this topic because this concept is required in solving the next question. So again, before I even tell you how it works, this is very simple. So far, as you have seen, F is equal to ma became tau equal to I alpha, T equal to mv became L equal to I omega. Similarly, kinetic energy in translation is half mv square. So kinetic energy in rotation will become half. Instead of m, it will become I. Instead of v, it will become omega. So this is what we are expecting it to be. Okay, straightforward. Now the derivation of it. So as always, there is a rigid body which is rotating and rotating with this angular velocity omega. The property of rotation motion is that when the entire body rotates, each and every particle of that body performs the motion with same angular displacement, same angular velocity, same angular acceleration, except for the particles which are on the axis of rotation. So if we try to write down the kinetic energy of all of them together, adding all those kinetic energies will give me the rotational kinetic energy of the entire rigid body. So half mv1 square or m1 v1 square plus half m2 v2 square. Like that, if I keep on adding the kinetic energies of all of them, we know that for different particles when they are moving in the radius or as a circle of radius r1, r2, r3, and so on, the expression which will still hold together and true will be equal to v equal to omega r. This is still holding true. Okay, so we can replace all v1, v2, v3s and vn with omega r. So omega r1, omega r2, omega rn, like that. So squaring that will give me half m1 r1 square plus half m2 r2 square plus half m3 r3 square, so on. Taking omega square common. So you see what is written here is nothing but moment of inertia. So the final result, as expected, is half I omega square. Plus 1 if you understand. Great, awesome, simple, as simple as that. Okay, great. Yes, Riddhiman. Yes, tell me. Yes, you are. Which part did you not understand? The entire derivation. This one. Here, do you see that it is half m1 omega r1 square? Like that, all the terms have a similarity. So can I say omega is one factor which is common in all the terms? Squaring that will take me or give me omega square, which I can take out of the entire bracket. So what I'm left with is m1 r1 square, m2 r2 square, m3 r3 square, so on and so forth. m1 r1 का भी square होगा ना? So m1 r1 square plus m2 r2 square, m3 r3 square, all of these are point masses. And when we write m into r square, that's basically the moment of inertia of the point mass. Exactly. So that's what it is. Okay. Okay. Everyone understands? Yes. Good. Very nice. Sure. Then let's have a look at an example and further more questions to solve. So have a look at this. This is the JEE Main 2020 question. Last year का सवाल है. Two uniform circular discs are rotating independently in the same direction around their common axis, passing through their center, and the moment of inertia and angular velocity of the first disc is given, and for the second disc is also given. That means the value for moment of inertia, angular velocity, I1 omega 1 is given, I2 omega 2 is given. At some instant, they stick together and start rotating as a single body. So definitely law of conservation of angular momentum will work. Okay, and about the common axis with some new angular speed. So question, instead of asking the new angular velocity, is asking you to find out the kinetic energy of the combined system. So basically, what we did here, this is half the answer. This is still half the answer. But question wants you to calculate the final rotational kinetic energy, which is half I1 plus I2 into omega square. Does it make sense? Because now I'll show you the solution also. This is what is happening in the question. The only part which is added is to find the rotational kinetic energy, and it is the JEE 2020 question. Okay. Let's go to see that question once again. So this is what is happening. This time numerical values are given, by the way. So I1 omega 1, I2 omega 2, and combined thing is I1 plus I2. Okay. I1 plus I2. Good. So you see omega is I1 omega 1 plus I2 omega 2 divided by I1 plus I2. When we simplify, we get the value of omega as 20 by 3 radians per second. Can we find out the kinetic energy now? Simple. It's going to be half I1 omega square plus half I2 omega square, or you can say it is half I1 plus I2 omega square. Simplified. Half I1 plus I2 का value 0.3, omega 20 by 3 का square, you can see. Simple, 20 by 3 joules. Okay. Okay. Good. Yep. So that's our answer. Option D. Believe it or not, JEE Main 2020 question. JEE Main 2021 further easy questions came. But don't think that similar will happen when you will appear for JEE. Okay. It is said that you should hope for the best but prepare for the worst. Okay. शुभ ही बोला मैंने, कुछ भी अशुभ नहीं बोला. Chalo guys, question in front of all of you. It says that a small block is rotating in a horizontal circle at the end of the thread which passes down through a hole at the center of a tabletop. वो जो rich लोगों की टेबल थी, टर्न टेबल, ठीक है, तो उसके सेंटर में एक होल है, there is a hole at the center of the table, there is a thread which is passing, and the portion which is on the top has a stone connected on it, and that stone is rotating in a circle on the table, and there is no friction. There's no friction. That's what we have to assume. Oh, in fact, they have said it also that you have to assume that there is no friction. Okay, so what you see in the diagram also, this is basically the table, and this is your particle. Okay, the block, and blue color is basically the thread, and you can pull the thread. If you pull the thread, the length of the thread on the table becomes less, which is basically the radius. Which simply means what? If you pull the thread is passing through the axis of rotation at the center, so it does not apply any torque. So there is no external torque that will get applied, and you're still able to change the angular. You're able to change the angular velocity. You're keeping the angular momentum constant. Exactly the same video that I showed you. That person was pulling that 3D object. The particles are coming closer. The angular velocity increased. Similar of that sort is happening here with one particle. So question says that the system is rotating at the angular speed of 2.5 rotations per second in a circle of radius 30 centimeter. So R1 is given. So omega 1 is 2.5 RPS, and R1 is 30 centimeter. So question says that what will be omega dash or omega 2 if radius is reduced to 10 centimeters, and it's a point mass whose mass value is not given to you, and that simply shows that will get cancelled, and it's a point mass. The block has to be assumed to be a point mass, giving you all the information. Okay, now I give you only 90 seconds, and the time starts in 3, 2, and 1. Find out the value of omega 2. I've given you 90 seconds, considering maybe it might be a little calculative. Otherwise, the concept is very simple. Sir, did you flex on your cousins and siblings when you got into IIT Bombay? Flex, I mean show off. Siblings, I have my elder brother, nothing to show off to him, and cousins were indifferent any which way. So I was already on cloud 9 that I did not have to show off to anyone. I was already so happy. Then I can now say, when I look back, thank God that I did not do any kind of show off of that, because I would be feeling bad about it today if I did. Okay, 20 seconds remaining. All of you. Okay. You heard that? You heard that, Rajkumar? And it's not bad luck. It's not bad luck that whenever the lecture comes in your batch, and only then, we have this sound. But let me tell you one thing: if you know a little bit about cooking, or if you have been in kitchen at least, just to see what happens there, khichdi is not the only thing which is made in cooker. Okay. Yeah, but definitely it is, and also it is not necessarily rice, by the way. Exactly. Thank you. बिरयानी के लिए कुकर नहीं लगता है. Let's not get into altogether different stream of discussion. Culinary discussion नहीं करेंगे हम लोग, ठीक है? हाँ. चलो. Yes. Homes. I know. Anyway, chalo, switching off the chat so that we come back to the question once again. So the answer is 22.5 RPS. That means we did not even require to convert this unit also, because again it is coming from law of conservation of angular momentum. Straightforward question. I1 omega 1 equal to I2 omega 2. You just needed to find out the moment of inertia, which is also very simple, mr square, right? Because it's a point mass. So m1 r1 square or m r1 square plus m r2 square. So simply if I look at it, I will not even write this much. I'll say that I1 is m r1 square omega 1 equal to m r2 square omega 2. Okay, m got cancelled. I need omega 2. Simply omega 1 r1 square divided by r2 square. That's what is written here. No? Okay, so omega को convert कर लेंगे B के case में. They're asking what will be the speed of rotation when the thread is pulled. So no problem. We'll find out the value of. Wait, just a minute. Wait a minute. We don't require V. Answer options are already RPS. So it's not V that we need. We only need omega. We need omega only. This is how you should write it. Okay. Answer is only mathematical. So I just did 30 minus 10. 20 into 2.5 equal to 22.5, and boom, very good. बस ये solve करना था. That's it. उसने लिखा, I just read whatever that person wrote there. Okay. Yes. चलो, question for all of you. JEE Main 2016, when things were not as straightforward in physics, long time ago. So this is the point which you have to choose as axis of rotation. Or simply, let me give you a visualization. Imagine a line that is coming towards you from point O. From point O, imagine an axis coming towards you. That is axis of rotation. And this object is moving straight forward, straight line motion. So its center of mass is moving. So center of mass, when the object is moving, it collides. This object collides here, and obviously when that object collides, this is what happens with it. Maybe here it collides. So it collides with that point and it topples like this. So when it topples, the axis of rotation passes through that point O. Okay. So basically, I'll give you that diagram where this happens. Just have to consider that situation when it is about to get toppled. Okay. When it abouts or when it starts to topple. So this is the center of mass C. This is O, and this is R, the distance from axis of rotation. So typically for a cubical object, if the axis of rotation passes through C, the moment of inertia about C, hope you people remember, for a rectangular plate, when the axis of rotation is this, the moment of inertia is 1 by 12 ma square plus b square. But if it becomes a square plate, not table, this becomes 1 by 6 ma square, where a is the side length, obviously. So now what has happened? The axis of rotation has shifted by a distance r. So I need to find out r also, by the way. So this is a by 2, this is a by 2, and this is the right angle triangle. I'm talking about this right angle triangle. This is r, c, o, a by 2, and a by 2. Okay. The diagonal is already root 2a. So when you do the maths, excuse me, r comes out to be a by root 2. You can do the maths by yourself for this. It's not that difficult. So you need IO. The axis of rotation is O, and moment of inertia will be IC plus mr square. theorem of parallel axis, because the axis got shifted from C. The axis is passing through C, coming towards U. If that would have been the axis of rotation, 1 by 6 ma square is the moment of inertia. Now it has shifted to O. So the new moment of inertia is ma square by 6 plus m. R ka value a by 2, O root 2. Squaring is ma square by 2. So that comes out to be 4 by 6 ma square. Okay, I'm just writing the moment of inertia here. So you need to find out the angular velocity of the block immediately after it hits the bump, and you have to conserve the angular momentum. Now, this is a 5-star question for the day, and for a long time we have not done a quality question like this, considering the beginning of this JEE preparation from rotation motion point of view. So definitely it's a very good question. Giving you guys 90 seconds to think about it, to further simplify it. If you get it, it's nice. If you're able to understand it, is also nice. And if you're not able to, you don't lose your heart on this. Okay, this is a real good question. Time for 90 seconds starts in 3, 2, and 1. I've given you the moment of inertia already. Okay. Okay. Okay, that's nice. Good. So yeah, first of all of you, when the center of mass is moving with a velocity v, the mass of the object is m. Can I say that I can write the angular momentum about O when the distance from the axis of rotation is, yeah, mvd, perfect. Distance from axis of rotation is a by 2, right everyone? So the initial angular momentum when we try to write is m into v into d. What's the velocity given? Velocity is given, numerical value is given. mvd concept, perfect. So mv a by 2, mv a by 2. That's your initial angular momentum. And final angular momentum will be io into omega. And I guess question is asking for omega only. Angular velocity. So we can easily find that out now. Do we understand it properly? Okay. But the correct answer is option A. So mv a by 2 will be equal to 4 by 6 ma square. 4 by 6 is 2 by 3 ma square, right? Hope you guys are able to figure that out. So m gets cancelled. This a also gets cancelled. Omega comes out to be 3v by 4a. V is given. A is given. A was given to you in centimeters. You needed to convert it into meters. Simplify that. Okay. Clear concept? Hopefully, yes. Okay, guys, one more question for all of you guys to try. This is an easy one, and that too from 2019. From 2015 to 2021, the JEE questions actually have gone very, very low in level. 2019 question is also straightforward. A thin, smooth rod of length L, mass m is rotating freely with angular velocity omega naught about an axis perpendicular to the rod and passing through its center. That means this is how it is rotating. Not 10 5. It is rotating about its own center. But two beads of mass m and negligible size are at the center of the rod. Let me explain you what does that mean. So maybe this is your rod, and it is rotating about its geometric center, which is passing through this point. Okay. So two beads. Beads are basically pearls. Hindi mein bolu to moti. Okay. So you can actually think of balls or rings which are placed here. As this this thing will start rotating, they will experience centrifugal force and they will actually try to go away from it. Okay, so what happens in the beginning? All the two masses which are given here, individual masses is m. So small m and small m both are here. Capital M is the mass of the rod. This is L by 2. So initially the beads are at the center, and it keeps on rotating. Initial angular velocity is omega naught. Finally they come to the extreme ends. Initially they are here. Finally they come here. So obviously the moment of inertia increases. Angular velocity will definitely decrease. How much it will become is what the question is asking you to find out. The new angular speed when the beads reach out to the opposite ends of the rod, giving you 90 seconds. Time starts in 3, 2, and 1. Thirty seconds remaining, all of you. Okay, last 10 seconds. And let's see. This was easy. Easy laga. See, the initial moment of inertia is 1 by 3 ml square. Sorry, 1 by 12 ml square of the rod. Correct? And what passing through the center. For a moment I was just worried. I2 will be 1 by 12 ml square. ये तो है ही. Plus two masses, each of value m will go to a distance L by 2 का square. So this is capital M L square by 12. All of you. And this is ml square by 4. So 2 ml square by 4. 3 से और multiply कर दो. So this comes out to be ml square plus 6 ml square by 12. That's what I get as the new moment of inertia. Yes, everyone? Capital ml square plus 6 times small ml square. That's it. So 12 cancels, L square cancels. So यहाँ बचता है m omega naught divided by m plus 6m. That's our answer. Okay. हाँ जयंत. Both of them are at the axis of rotation, so their moment of inertia is zero. That's why. Others understood this? बाकी लोगों को समझ में आ गया? Okay. Very nice. So one bonus question. This is from JMA 2019 only. That's a bonus question. I did not think that we'll do this, but it's good that we have done this so far. Okay. No problem, Nishal. So everyone pay attention to the question. We have this randomly shaped curve given to us. And maybe this is more of a bowl. It's a bowl whose side view is given. And this bowl is not rotating. Okay. But the object is basically a ball which is having a mass of particle. It is actually of mass 20 grams. It's a particle. Okay. It's a point mass. Let's read the question. A particle of mass 20 grams is released with an initial velocity of 5 meters per second along the curve from the point A. So from point A, you release this. Maybe it slides. It does not roll. Okay. There is no rolling happening yet. It is still sliding only. So when it slides down, it reaches this point B. The particle slides along. It is sliding down. Question confirms on a frictionless surface. So when the particle reaches point B, obviously its velocity also changes. So now considering O be the axis of rotation, about O you have to write down the angular momentum when the object is at B. Okay, that means MVD is being asked. D you will have to figure out. Mass of the object is given. V you will have to find out. So to find out VB, I have given you the hint. You can conserve the energy between A and B. Find out VB and then put it here. You'll be able to get this. Okay, giving you 2 minutes and the time starts in 3, 2, and 1. Come on, everyone. Okay, half time is gone. 60 seconds remaining. Okay, last 30 seconds. Okay. So when we equate the energy, let's consider that this point is h equal to 0. So energy at A will be equal to energy at B. At A, the energy is half m, and initial velocity is 5 square plus m into g into height, that is 10, will be equal to kinetic energy half m vb square plus 0 potential energy. So m gets cancelled, 2 you can cross multiply. So this will become 25 plus g is taken 10, 10 into 10 is 100 multiplied by 2. This is 200. 2 also multiplied. So vb square is equal to 225, and 225 that means 15. So vb comes out to be 15, and then put it here, get the answer. Okay, MVR. Mass is 20 grams converted to kgs. Velocity, sorry, this is the overall d value. Okay, I will call it d, and this is the entire value of d, which is 10 plus 10, 20. Make sense, all of you? That's it. So 6 kg meter square per second. Thank you. Yes. Yes, Riddhiman. Riddhimana. Tell me, क्या नहीं समझ में आया? लॉ ऑफ कंजर्वेशन ऑफ एनर्जी नहीं समझ में आया? ये समझ में आया? ये आगे बताओ. ये समझ में आया? So उसके बाद में about this point, the body has reached here. It has a velocity vb. So can I see it as it is passing through this point? This is its distance d. So this is my axis of rotation. This is d distance. Mass of the body is m. So m into v into d. That's its angular momentum. Yeah. Video link. हाँ चलो video link पहले share कर देता हूँ. Just a second, all of you. So let me share this first. So this is a video of my journey of JEE preparation that came on Vedantu's JEE channel. It's Vedantu's JEE channel on YouTube. If time permits and you're interested, then you can watch this video. Okay, and share with other friends if you want to. Okay. And before we go any further, this is the leaderboard for all of you. Congratulations, Gunyar. Amazing, I would say, 1,000 points crossed. Well done, all of you. In fact, good job, yeah, good job. Well done, awesome. Great. So taking this off from the screen in 5, 4, 3, 2, 1. That's it. Okay. This is as always. You guys won't exit the session before this happens. So let me fulfill your wish. At my end, it doesn't make any sound. Okay, so with that, the class comes to an end officially. Class teachers, Feel free to leave the class once your doubts are done. Students who want to exit the session can exit the session as well. And switching on the chat. Okay, all of you, आज तो सब समझ में आ गया होगा यार. Easy था आज का session. So there are many PYQ and JEE main from this chapter. Absolutely yes. Bye, PK Sharma sir. Bye bye. Sir, we forgot one thing we can make in Kuka. We forgot multiple things. Sir, how D equal to 20? Axis of rotation is here. This is 10. This is 10. So total distance becomes 20, right? हाँ जयंत. कुछ समझ नहीं आया तुम क्या बोल रहे हो. This one, okay. LCOM is angular momentum of this entire body about an axis which passes through the center of mass. Now the axis of rotation is passing through a point which is not passing through center of mass. Any other point. Any other one. It can be in the body itself. It can be outside the body also. Yes. That's it. Okay. Cool. Class is over. Yes. Apurva. Apurva. Hello. Apurva, you're not audible properly. Can you speak louder? Good evening, Apurva. Last session, last 15 minutes. Go through that. I have explained only this part only. Watch that part one more time. You will understand it properly. That comes with practice, definitely. We will solve more questions on that. Okay. So did you clear India? Yes, I did. But I could not go for the SSB interview because the dates were clashing with J. So in slide 51, why did you take I as MR square when it mentioned about a block Diksha? Slide number 51, slide number 51, slide number 51. I guess this one. I have told you that because nothing has been talked about the body, so I'm free to choose it as a point mass. Okay, Diksha. Which question, Ansh? Yeah. Yeah. Uh-huh. सोचो अगर ये पॉइंट मास होता और ऐसे मूव कर रहा होता बुलेट की तरह, तो इसका एंगुलर मोमेंटम में लिखता m into v into d, है ना, बुलेट वाला सिचुएशन. तो वो बुलेट वाली सिचुएशन इस ब्लॉक के साथ बिफोर इट स्टार्ट्स रोटेटिंग, पहले एक्चुअली रोटेट कर नहीं रहा है. इन सच क्वेश्चंस व्हेन डू वी राइट mvd is when there is a possibility that eventually the body will rotate. Okay, like the situation which I shared here also. Here we wrote angular momentum of the bullet if we want to as m into v into l, right? Only when we see there is a possibility of rotation eventually. So I told you that here it is still not required, but this is precisely the situation where I'm sure that the body is not right now rotating, but once it hits that point O, it will rotate. Okay, and when the body is going to be hit by this point, the force will pass through the axis of rotation because this is the point where force will act on the body. Right? So force will not be able to generate any torque. And when no external torque acts, angular momentum has to be conserved. Correct? So when the body was just translating, I will write its angular momentum as mvd. तो जो सेंटर ऑफ मास है उसके पॉइंट ऑफ व्यू से लिख दिया मैंने, उसको एक पॉइंट मास मानते हुए उसका एंगुलर मोमेंटम लिख दिया. आया बात समझ में? पक्का? ठीक है. उसके बाद में जब बॉडी यहाँ आ गई, ओ पे जाके हिट कर गई, तो अब बॉडी ऐसे रोटेट करना शुरू करेगी विद एन एंगुलर वेलोसिटी ओमेगा. तो अब क्योंकि बॉडी एक रिजिड बॉडी की तरह रोटेट करने वाली है, तो नाउ द एंगुलर मोमेंटम विल बी रिटन एज I2 ओमेगा. Because different points will move in the different circles. जैसे सेंटर ऑफ मास a by √2 के डिस्टेंस पे है, जबकि ये पॉइंट p जो है ये √2 a डिस्टेंस पे है, ये वाला पॉइंट a डिस्टेंस पे है. तो different points moving at different radius. So that's why I need to write the angular momentum as I omega. Okay. Cool. Sir, can you please show the slide of question number where two metal blocks of mass 5 kg held by a rotating person? I guess this one. Hridaya? Okay, this is the question. Solution. Okay. ठीक है एवरीवन, आज जल्दी रैप अप कर दें. चलो बढ़िया. फॉर अ चेंज लेट्स रैप इट अप विद इन टाइम टुडे. विल मीट अगेन ऑन वेडनेसडे एनी व्हिच वे. ओके. अरे आशीष वांट्स टू स्पीक. ठीक है. हाँ आशीष, गुड इवनिंग. बोलो बोलो. हैं सवाल याद ना. कौन सा 3 व्हाट? वो अच्छा पिछली बार तो तुमने सवाल पूछा था, दोबारा ट्राई करो एक बार और. मैंने कोर्स समझा दिया तुम्हें, एक बार और ट्राई करो उसे. ठीक है. ये तत्व का क्वेश्चन है क्या? असाइनमेंट का क्वेश्चन है. ठीक है. क्वेश्चन एक बार मुझे सिर्फ पढ़ के सुनाओगे क्या बोलता है? पढ़ के सुनाओ प्रॉपर क्वेश्चन. तो एक काम करना, मुझे अगली क्लास में उसकी स्क्रीनशॉट रखना, तब तक एक बार ट्राई कर लेना. वेडनेसडे को जब दोबारा से क्लास होगी तब पढ़ के मुझे सुनाना, अगर नहीं सॉल्व हो तब तक भी. ठीक है. क्योंकि अप्रोच एक्जैक्टली वही रहेगी, चेंज नहीं होगी. एटलीस्ट अगर सवाल वही तुमने जो बोला था वो है तो. ठीक है. चलो नेक्स्ट टाइम देखते हैं. ओके, गुड नाइट. ठीक है. चलो गाइस, क्लास टीचर्स अंशु सर, ओके, थैंक यू मुनिया, थैंक यू सो मच. चलो गाइस, साइनिंग ऑफ टुडे. आई विल बी सो हैप्पी. हाँ विहान, आज जल्दी जा रहा हूँ. और तुम पिछली बार आए नहीं थे तो पिछले साल का क्लास का वीडियो जरूर देख लेना. ठीक है विहान. और गणपति बप्पा के गणपति विसर्जन में बहुत ज़्यादा बिजी मत हो जाना. यस. ठीक है. चलो देन. अरे आई नो दैट कि अगर कोई मुंबई का लड़का क्लास मिस कर रहा है तो डेफिनेटली गणपति वाला दिन है, तो और कोई रीजन हो ही नहीं सकता है. आई नो. ओके. चलो देन. ओके विहान, सी यू नेक्स्ट टाइम. सी यू ऑन वेडनेसडे. या बाय बाय, मैं चला केबीसी देखने, बाय बाय, गुड नाइट, सायोनारा, हasta la vista, बाय बाय।